So today we will do the next in the continuation of measurable sets. The next in the continuation of measurable sets is Lebesgue measurable sets is sigma algebra. So the question is, what is a sigma algebra? A collection. So we will write the collection in a cursive set of subsets of x is said to be sigma algebra if, number one, the whole set A X belongs to the collection. Number two, if we have A1, A2 and so on up to, we have infinite collection of sets, they are coming from the collection A, then it implies their union ironing from 1 to infinity A, and that belongs to the sigma algebra. Number three, the difference of two sets, if belongs to A, then their difference, if the two sets A1 and A2 belongs to A, then their difference also belongs to the collection, where A1 and A2, they are coming from the collection A. So what is the collection A? It is the subsets of X. X एक set लेंगे, suppose we have a set X, उसके जितने भी subsets बनेंगे, right? उन सारे subsets को हमने collection A में include कर दिया, और अगर वो collection जो है इन तीन properties को satisfy करती है, it means that set is said to be a sigma algebra. Now we have some of the properties of sigma. Next, you will write the properties of sigma algebra. So whenever you will write sigma algebra, it means we are talking about a collection. A collection is nothing but a set which satisfies some of the axioms. Number one, the whole set X belongs to the collection. The union, countable union of all the sets which are coming from sigma algebra, their union belongs to the set, and the difference of two sets belongs to the sigma algebra if the elements are belongs to sigma algebra. So now we will work on the properties of sigma algebra. Number one, if a set A belongs to the collection A, sigma, then if A belongs to the sigma, यहाँ पे sigma algebra कौन है? ये है, right? If A belongs to sigma algebra, then A complement also belongs to sigma algebra. Let's come to its proof. Now X हमें पता है by the axiom. Now X and A, they both belongs to the sigma algebra. It implies by the third axiom, X minus A belongs to the sigma algebra. And what is X minus A? It implies A complement belongs to the sigma algebra. So this is the property number one. Now coming to the property number two of sigma algebra. हाँ जी, so statement is sigma algebra. What is the collection A? The name of the collection A is sigma algebra. Sigma algebra is closed under countable intersection. Is closed under countable intersection. That is if A1, A2, so on up to AN, so on up to chalta jayega. This belongs to A. It implies intersection I running from 1 to infinity. AI belongs to A. This we want to prove. So let's come to its proof. Hanji. So as A1, A2, सारे जो sets are there belongs to A, right? And the second property states that by property 2, Their complement, A1 complement, A2 complement, they all belongs to the collection. And by second property, by second axiom, their union, I running from 1 to infinity, AI belongs to the sigma algebra. Now we will apply De Morgan's theorem. It implies intersection, I running from 1 to infinity, AI its whole complement that belongs to sigma algebra. आप यहाँ लिखेंगे by De Morgan's law. ठीक है जी? Then after this, what you will write? You will take its again complement its complement. Again, it belongs to the sigma, it belongs to the sigma algebra. This again by the property number 2. And the complement it sets itself. It implies union I running from 1 to infinity. AI belongs to the sigma algebra that I want to. So this is the second property of sigma algebra. Now we will come to its third property. Property number 3. So what is the property number 3? The collection M of all measurable sets is a sigma algebra of sets in P of R, that is power set of R. So what is the statement? Collection of all measurable sets of sets in PR. सबसे पहले R है set of real numbers. ठीक है जी? R we have the set of real numbers. What is P of R? जितने भी इसके subsets बनेंगे, subsets, all subsets of R, and the name is power set of R. ठीक है? First of all, we have the set of real numbers and we will find out the all subsets of R. Then what is M? इस collection में से जो sets measurable है. This is M is the collection of measurable sets of P of R. इस PR collection में से जो measurable set है उसका नाम क्या है? M. To prove क्या है? M is sigma algebra. यानी collection of measurable sets which are coming from the power set of R, we want to prove that that is a sigma algebra. Now this will be sigma algebra if it satisfies the three axioms. Number 1, the set itself, the whole set itself, R must be contained in M. ठीक है जी? I'm writing. So what to prove? To prove M, the collection of measurable subsets of P of R is sigma algebra. That is to prove number 1, R belongs to M. Number 2, union I'm running from 1 to infinity, AN belongs to M. And number 3, A1 minus A2 belongs to M. ठीक है जी? So M that you will write, it's not a simple M. It should be written in a cursive form. So let's come to its proof. Since अब इस कलेक्शन में कौन आएगा जो क्या है? मेजरेबल. सबसे पहले वो मेजरेबल होना चाहिए. We know that since R is a measurable set. ठीक है जी? It implies R किसके अंदर आ गया? First property done, right? First property is done. Second property. Let हमने ये सारे सबसेट्स लिए, let A1, A2 ये सारे किस में से आ रहे हैं? इस कलेक्शन में से. ठीक है जी? आर मेजरेबल सेट्स. और ये सारे, it implies A1, A2 so on up to this is a measurable, is a collection of measurable sets, right? And we know that the countable union of measurable set is measurable. Countable, as you will write as countable union of M is measurable. Measurable sets is measurable. It implies, I'm doing the same question on a single page. It implies union and running from 1 to infinity. An is measurable. क्योंकि M में वही आएगा जो क्या है measurable है. तो ये किसको belong कर गया M को. Second property term. Now third property. Now A1 and A2 दो sets लिए हमने M में से. Right? Or it implies A1 and A2 are measurable sets. And we know that the difference of two measurable set is measurable. Either you can write or you can prove. It implies A1 and A2 complement is measurable set. ठीक है जी? It implies A1 intersection A2 complement is measurable set. It implies A1 minus A2 is measurable set. So हमने third property में दो sets measurable लिए और prove कर दिया the difference of two measurable set is measurable by using that if A1 is measurable then its complement is measurable. This is one of the property of Lebesgue measurable set. ठीक है जी? And this is a measurable. An intersection of two measurable set is measurable. We have already done previously. And what is A1 intersection A2 complement? This is A1 minus A2. So this is a measurable set. It implies, last में how you will conclude, it implies the collection M of all measurable sets is sigma algebra. Is it clear? It's clear to all of you?
Yes, ma'am.
Yes, ma'am.
Okay, so now we will do some of the examples. Number one example. Now the first example we will do, show that if E is measurable set, this is E I have written, then each translate E plus Y of E is also measurable. And measure of E plus Y is equal to measure of E. We have already done this question in outer measure. This is one of the property that the outer measure M star is translation invariant. So here you can write in or the Lebesgue measure. The Lebesgue measure is translation invariant. So this is one of the property of Lebesgue measurable set. So let's come to its proof. Since E is a measurable set, M means measurable set. ठीक है जी? Then for any set A, we will write the definition of measurability. Sorry, this is M star A is equal to M star A intersection E plus M star A intersection E complement. ठीक है जी? Now using the translation invariant property of outer measure. Outer measure में तो ये property पहले ही hold हो रही है, ठीक है जी? Number one, then one becomes. So क्या करना है हमने? हमने a में y ऐड कर देना, m star a plus y, m star a intersection e, put in bracket, then plus y, then m star a intersection e complement plus y, right? So we know that it is translation invariant. So first of all, what you will do with this is a plus y a plus y intersection e plus y. ठीक है जी? And this is m star a plus y intersection e complement plus y. Right? So next in the continuation is, so we have already written, or you can write here, it implies m star a plus y, this is equal to, so we have already written here, so this is m star a plus y intersection e plus y, then m star a intersection y, right, plus this was e complement plus y, right? अब हम अगले में क्या करेंगे? This will remain same. Plus m star a intersection y, and I can write this expression as y e plus y, or y plus e, one and the same thing, e plus y its complement. तो क्योंकि complement तो एक सेट का आना है ना, जिस एक पॉइंट से जिसको ट्रांसलेट किया है उसका कॉम्प्लीमेंट नहीं आएगा, ठीक है जी? सो यू कैन राइट हियर e plus y its complement is equal to e complement plus y. Now a, since a is any set, since a is arbitrary set, so replace a y a minus y, a की जगह a minus y कर देंगे, right? We get, so here what you will get, a की जगह जब आपने a minus y लगा दिया, so you are only left with a here, plus e intersection e plus y, plus m star, same you will left with here m, क्योंकि आपका y कैंसिल हो जाएगा, here m star a intersection e plus y complement. Because what you want to prove, that you want to prove that कि measure of जो e plus y के साथ सेट बनेगा वो भी मेजरेबल होगा, ठीक है? तो यही हम प्रूव करना चाह रहे हैं. ये बन गया, देखो m star a is equal to m star a intersection, एक सेट ये बन गया और ये सेट ये बन गया. इससे क्या पता चला? इट मींस e plus y जो ट्रांसलेट हमने किया सेट को इज मेजरेबल. सबसे पहले तो हमने ये प्रूव किया. So we have proved that e plus y is a measurable set. Now we will prove the measure. Now therefore अगर e plus y measurable है तो measure of e plus y, then measure of e plus y is equal to the outer measure of e plus y. So we know that the outer measure is translation invariant. So this is equal to m star e, and m star e is again m of e, क्योंकि e क्या है? Measurable है. E measurable है तो m star e, m of e is equal to m star e. This you want to prove that measure of e plus y is equal to measure of e. So we have proved that e plus y is a measurable set, number one, and e plus y is, and Lebesgue measure is translation invariant. दो पॉइंट्स जो हैं वो हमें यहाँ पे प्रूव कर दिए, ठीक है जी? So this means the Lebesgue measure is translation invariant. So this is all about today's topic. I hope the